Hello, so we'll do the dependent events task and show you all what you were getting confused at. So we have a tree diagram and we have a purse with American quarters, which is Q, and 46 euro coins, which is E. So you can either choose the quarters or you can either choose the euros out of the bag and you pull out two at random. So it says fill in the probability tree and then use it to calculate the answer. So if we look at this here, then if there are 41 and 46, first thing I want to do is add them together to get the overall total of coins, which is going to be 87. So if Q is the American quarters, that gives me 41 out of 87, and that leaves 46 out of 87 euros. Now, by pulling out, it doesn't say that we put it back into the purse. So that means that when we take one out, it's going to reduce. So if I take out a quarter, then I'm only going to have 40 over 86, so without replacing. If I take a quarter, then it means I didn't take a euro, so that's going to stay the same. However, the total will still drop by 1. Then if I take a euro, the quarters are going to stay 41, and the total is 86. And if I take a euro, it's going to drop to 45 over 86. So if I want to work out the probability of QQ, then that's going to be 41 over 87 multiplied by 40 over 86. So if I want QQ, it's going to be 41 over 87 multiplied by 40 over 86. And if you put that into your calculator, because you're allowed a calculator for these types of fractions, that gives you an answer of 820 over 3,741. So it's quite a large probability, and that's why the fraction box is big enough for you to enter these numbers. So that would be QQ. So if I rub that out and then look at the next one, the next one's going to be QE. So Q means choosing a quarter first, which is 41 out of 87, and E, then a euro, which is going to be 46 out of 86. So if again I multiply that, then the denominators stay the same, but the numerators will change from the previous calculation, and that's going to give me 943 over 3,741. Now, the last one is a probability of no match. So when it says no match, I guess it means that they're not matching. So the probability of them not matching is going to be the probability of QE times the probability of EQ. Now, if we do EQ, we're going to get 46 over 87, so it's a slightly different calculation. So we know QE is 943 over 3,741, so I'm just going to leave that there. But we also need to work out the probability of EQ, so the other combination of not matching. And that's going to be slightly different because it's E first, which is 46 over 87, multiplied by 41 over 86. And when I put that into the calculator, it's going to give me the same answer. So you might have spotted that just because the numerators are switching, it's like doing 2 times 4 and 4 times 2. So in math, instead of doing it the long way, which I just showed you, you can just times this by 2. So if you times that by 2, then you're going to get 943 over 3,741 times 2, which gives you a total of 1886 over 3741. So when you times by 2, it's just the numerator that gets times by 2. The denominator stays the same, and the numerator is times by 2. So that's how you do the first part. Now on to the second question. So this time it's another tree diagram, and what you need to understand is that the L naught, which you see here, means not L. So it says the probability of passing a driving exam with L lessons. So this is with lessons, and this is not lessons. So that means this little apostrophe that you see means not having lessons. So just in case you've forgotten that, that's the first thing you need to understand. Then understanding the letters, so lessons for L, not lessons for L dash. P is passing and not P is not passing. So we've understood the problem. Now we need to look at the different probabilities. So in the first section, we've got the probability of passing a driving exam with lessons is X. So probability of passing with lessons is X. Then it says, and is 0.4 without lessons. So I'm guessing this one has to be 0.34. And it says that 56% of students take lessons. So this means that this must be 0.56 because 56% take lessons. And this must be 0.44 because 0.56 plus 0.44 equals 1. So out of 100% in essence that you're looking at. Right, now if this is x, then this must be 1 minus x. And if this is 0.34, this has to be 1 minus 0.34, which is 0.66. So that's the tricky bit that most of you are probably finding difficult, understanding the problem, putting the correct information into the tree diagram, and then that leaves us with our calculation. So a student is selected at random. Fill in the probability tree and use it to calculate LP. So LP is this one and this one. Sorry, that's LP dash. This one and this one. So therefore it's 0.56 times x, which we would just write in algebra as 0.56x. So that's straightforward if you got your tree diagram correct. Then the next one is L dash, which is this one, and P dash, which is this one. And that's going to give me a numerical answer. So 0.44 times 0.66, which I'm going to write in decimal form, which is 0.2904. So that was 0.44 times 0.66. That's what gave me that answer, if you're unsure. Right, now if we look at our answer here, it says select the expression for a pass. So I can see that my two answers above are matching some of these answers below. So I know that I've done it right. Now I just need to select the expression for a pass. So when you're understanding probability, what are all the options of passing? In order to pass, I need to do a lesson and pass. And I need to do, in fact, let's highlight it. I need to do a lesson and pass. That's one outcome. And I need to do no lessons and pass. That's the other outcome. So if I think about this and write it down, I need to do the probability of L and P plus the probability of L naught and P. Now, do I have any of them? Yes, I have L and P, but I don't have L naught and P. So I need to work out that. So L naught and P is equal to 0.44 and 0.34. So if I multiply them together, that's going to give me 0.1496, which again matches one of the numbers down below. So which one is it going to be a pass? So if I add this with this, let's highlight them in green, this and this, if I add them together, that's going to give me this one here. So that would be the expression for a pass. Okay, I hope that has been useful for you and that can help you now try to do the task on your own.